Well, first of all, the thin layer that we use in the ductile provides the possibility of unlimited geometries, which is actually the manifest on the actual panels that we have. We can see different geometries applied to it and at different distances. Also, the material is very dense, especially for the UHPC material that we use. The quality of the material is defined by the exceptional high strength and durability of the material. The compressive strengths of the UHPC is actually 29,000 psi, which is the pounds per square inch, and that is actually 5 times stronger than a regular concrete that can be used in projects such as this one. Also, there's a waterproofing material that is used on the ductile that allows us to use it as an outer layer and to be very effective for a house such as this one. Lastly, there's two features to the concrete that helps a lot in this project, such as the air sealing and filtration, which helps with the reduce of air filtration that goes through the house. And also there are thermal properties that reduce the heat conduction through the walls, which helps us with the insulation performing at higher levels and increasing the R value of the concrete wall.
The grid house is using a sandwich panel for the exterior walls. The sandwich panel is typically, traditional sandwich panels is composed by a layer of regular concrete, 3-4 inches, then 3, 4 or 5 inches of insulation, and then the exterior layer another 3 inches of concrete. That's how typically a precast panel is made. For this particular house, we are using ductile for the exterior layer of the concrete. So we are reducing the 3 inches of concrete from 3 to 1.25 inch. This is possible because ductile, which is a product made by Lafarge, a French company, is an ultra high performance concrete that has a much higher compressive strength than regular concrete. So regular concrete for precasters is typically 6,000, 7,000 psi. Ductile reaches up to over 25,000 psi. That makes it 4, 5, 6 times stronger than regular concrete. So this allows us to reduce that thickness of that layer, therefore reducing the overall weight of the composite panel. So that way we have an exterior wall that is not only strong and resilient, but it's also thinner and lighter. Ductile also is a denser material, so it behaves much better against moisture, and so that way makes the house a lot simpler, the assembly of the wall, compared to traditional precast concrete. Also ductile, because it's a self-leveling concrete, doesn't require vibration, because also doesn't require rebars or reinforcing with steel, because it has some fibers on it, so that way we can reduce the thickness. But also because, as I said, it's self-leveling, there's no vibration required, you can get a lot more detail in the texture of the surface than traditional concrete. So to a point that we were able to include LED lights on the facade that are we can use at night. So we have some reveals on the surface of the house, of the surface of the wall, that at night can shine and emphasize some of these vertical features of the texture.